Hello, my name's Paul Harrison and this talk will be an introduction to using VODSL. Most of this presentation will be devoted to a live demonstration of the VODSL editor, as VODSL and its motivations were presented at the Madrid Interop around 3 years ago. The full presentation slides can be found on the meeting website. The first thing that you need to do, if you don't already have it, is to download Eclipse. You can do this from the Eclipse website and just go to the download page and get yourself a version of Eclipse Neon, which you click on this here. Once you have that, you can click on the installer, start it up. The installer gives you a number of options, but all we need is one of the simplest, which is the standard Eclipse IDE for Java developers. So we select that and choose a place to install it and then say install. Once it's successful, you can launch it directly from the installer. And it will request that you specify a workspace. This is just an area where it stores all of the files for Eclipse, so you can specify the name that you want. Yes. When it first starts up, you will see this welcome screen, so we can stop that from happening and go directly to the workbench. Also, in this demonstration, we don't need the task list, so we'll remove that for now. So the first thing that we have to do is install the VODSL plugin itself to add that functionality to Eclipse. We do this from the Help menu, install new software, and we have to add a new custom site to install that from. This is where I upload the compiled versions of the plugins. Say OK. Now we just need to load the VODSL feature itself. We don't need to load the sources. We should make sure that this contact all update sites during install is clicked, because it needs to find further standard plugins and Xtext plugins that are used by the VODSL plugin itself. You get a warning about software being installed that hasn't been signed. This is because I haven't signed these plugins, but you can just check that they are VODSL plugins that it's talking about and continue. At the end, you have to restart Eclipse for the plugins to be installed. Now that the plugin is installed, we can begin to use it. If we go to the File menu, and first we have to create a project, which is just a container within which you can add files. We can just create a plain project. And to create our first model, we just need to create a file which has a VODSL extension. So it will ask you whether you want to convert VODSL to a Xtext project, which is necessary for the VODSL features to work. We start our model file, and immediately we can start using Eclipse features. So we can use the IntelliSense pop-ups to use a template to create a new template. I'm going to say my model. We can also do an include of the base IVOA model definitions. These currently are, well, we have here referencing those models definitions that I have stored on GitHub, but in principle these can be included from anywhere, including local directories or on the IVOA website, for instance. And then we can just begin creating our model. So at any point we can use IntelliSense again. We can sort of decide, make ourselves a primitive angle. Needs a description. Of course, we should really be writing something sensible in these descriptions. We can put and we notice now immediately for this particular member attribute in VO DML terms, we can see the list of both our locally defined primitives or data types that we can use, as well as the ones that have been imported from the standard IVOA model. So we can put that in. We can also see some other Eclipse features up out on the right hand side here. The outline is being shown, so we can use that as quick navigation if we have a larger model. We'll see that a bit later on with some larger models. It can be useful to be able to navigate with this. As well, if we actually save this, we will get rid of that error that we saw there. But you can see that errors will actually be formed as we type. In that particular case, because we hadn't done the first save, it hadn't quite got the fact that we had now what is a complete model that is actually a valid model. And in effect, this can be our very first model, our Hello World type model that we've made using VODSL. Also, by saving, you'll see that it automatically generates a standard VODML XML version of the model. So if we look at that, we can see that it has all of the standard parts that it should have. Some things here that still have to be sorted out in actually producing some of those standard parts, but in general most things are properly transferred across. In addition, we can just check that that is actually validated, because you can see it, and it does validate with no errors. As we can see here, we have it validating against the standard location for the VODML schema. Now have a more detailed look at some of the features of the VODSL editor by looking at some of the models that have already been prepared. These exist in a GitHub repository that's IVOA VODSL models, and we can import that directly into our newly running Eclipse with its VODSL features enabled. So we just do an import of existing projects into the workspace, browse to where these projects have been downloaded, which is here. Once they finish, we now have these models directly in the workspace. One thing we might do, just so we're not overwhelmed by lots of error messages, is we just show the errors and warnings on the selected file that we have. Okay, so inside here we have an example model which attempts to show a fairly large fraction of the VODSL language. Now clearly, if you're familiar with VODML, then you should be able to recognize what most of the types, most of the expressions here mean. but you'll see they are expressed, or the attempt is to express these in a more sort of standard English way than certainly the XML does. We can create packages, and as you can see, we can use an Eclipse feature where we can collapse the whole package or collapse parts of definitions. Useful again for being able to navigate as well as being able to use the outline navigation over here. Express things here like this is the multiplicity for this particular attribute, and we can in fact potentially make an error here, and we should be able to see that we now get an error and immediate feedback that we have something wrong here. So it says attribute also should be a value type, but it's because it doesn't recognise this type at all here, and then it says it can't resolve that definition type. Extra. So we can just hit the control space again to get auto completion. Of course, it will give us the correct answer almost straight away. And we've got, I mean, that facility is quite useful for allowing you to express the correct syntax immediately using the IntelliSense and the auto completion. And there, particularly when you've got some quite complicated expressions within the VODML language. And one of the most complex here is subset, where the idea is that a derived type can also have one of its attributes also defined as derived from an existing attribute, so it becomes more specialized than in the base type. And so that actually puts quite a few constraints on a particular type. So if we have a look here, we just delete this for now. So you can see, because we're deriving this derived to from derived, then there's only a certain number of things that we can actually subset potentially. They have to be attributes of the base types. So we choose one of those. And then because of that, in fact, our choices are almost completely limited, because then the actual type that this becomes needs to be a subtype of the originally defined type. So again, there's very few legal actual possibilities in that case. Again, if we actually save this, hopefully the existing errors on this file will go away. As well as these standard sort of test models and toy models that exist within this models collection, you'll be able to see that there are familiar names amongst these model files and these are models that have been derived from the standard models that have been written in VODML that exist within the Volute repository. These have all been translated into VODSL by using this XSLT script here that can be run with this build and file, and that can give can allow you to rerun the translation right the way from the start, or you can just do a few selected translations. I have probably made some hand edits to some of these files that exist within the repository, just creating some of the, or just correcting some of the most basic mistakes, but by and large there are not large edit changes. So some of the errors we see here are real errors within these models as expressed, but in many cases this is potentially because some of these models haven't been updated that recently. And so the cleanest models, as you'll probably see here, are these STC ones, which have few or no errors, in fact, when you actually look at them. And for instance, STC codes just has a couple of warnings. For instance, having strongly discouraged attribute multiplicities here, for instance. I think this STC trans is probably has become slightly out of date because the file names have been changed actually, so we can probably fix that quite quickly, hopefully. So we're left with a couple of problems still. That's because that's chords. Probably. Chords as well. Another error here. Chords again. Maybe not this time. Okay, it was more difficult to solve error, so we want a pole chord there. Let's see if we can find one. Is that the one we want? Anyway, I might be wrong, but you can see that I can quickly find something that is potentially the right thing there. In conclusion, I would just like to put this slide up that shows the comparison between the VODSL route and the traditional VODML route via the UML editors, and just point out the advantages that there are in the VODSL route. Additionally, as a teaser, I'd like to say that I have just started work on a graphical tool extension to the editor that will allow visualization of parts of the data models.